our new walk-in enclosure product, which is really around the requirements of big hyperscale data centers. And as they expand, their power requirements becoming more complex, more demanding, whether that be noise, emissions, power density. And again, the requirements that they're looking for in terms of serviceability and the product over the product's life still being key to what they want to achieve. So we've been able to now come up with the product where we're able to offer internal cooling within the enclosure itself as an option. So we can have either external or internal mounted cooling systems. We've got set mounted radiators on the genset base frame for all of our models, which obviously reduces the amount of equipment assembly on site. And it allows us to then bring the units to site in modular form with the main walk-in enclosure delivered as a unit, and then mount that on the external civil works concrete slab with all the options already connected and tested, allowing it to be a quick installation, minimal amount of site time, minimum amount of man hours on site. And these allow data center operators to use the highest power machines available without compromising on any of their requirements for the long-term serviceability, operation and maintenance of those units. So an overview of those. Obviously, one of the main constraints with this type of equipment is transportability and being able to transport it on vehicles that can achieve the maximum load heights for motorway bridges and that sort of thing. But the way we've designed this is to keep the core part of the unit to a transportable size, and then things like you see on the left of that drawing there with attenuation, air outlets, exhaust, all built as modular units that are delivered to site and then craned into position and just fitted up to the main unit. And this would be a unit that typically we would have built prior to delivery to site for the customer to witness and test. Quite often the customer will do a type test. So they'll have a number of units built and tested as a complete assembled unit. And then we would then deliver the rest of the units to site and assemble do the final assembly work on site itself. And again, the concept of the design around this was this been to take into consideration all of the various requirements that we see from our large customers of these types of units. So again, you get a number of things that are fairly standard or typical in terms of what's requested. And then again, we can adapt and have the flexibility to make those adjustments or changes that a particular customer wants, whether it be the way the air outlet is arranged, the inlet, the position of certain things. So it allows us to have a quick way of being able to engineer actually a bespoke solution by having quite a lot of the engineering work done, the structural engineering, the design of the unit, the ability to understand noise requirements and how that will impact the unit itself, and then adjust that for each individual requirement that a customer may have on their site.
Yeah, just on the sustainability, net zero, I mean, we're all acutely aware of what's going on, both nationally, globally, COP26 and all that. Do you have any thoughts as to where the data center industry, I guess there's two sides, there's the supply side and obviously then the data center operators. Any thoughts as to sort of where those people, those two groups are and where they need, I mean, everyone talks about net zero, so clearly it's a great ambition, but is it a bit pie in the sky? As you alluded to in your presentation, we need to be a bit more sort of realistic as to what is achievable over what kind of time frame.
I think the desire is there and the will is there. I think if you look at the data center industry, and I sort of touched on it when I talked about supply chain, there are data center operators, customers out there that clearly want to be at net zero or improve what they do. I think that there are things that are being done today. There are data center operators out there that plant millions of trees to offset what they see as being their footprint. There are those that are buying green energy, but I think the fact remains at the moment that there's a sort of a balance between that sort of ability to be able to have the 5 nines reliability, and I think generally the grid and the network that most of these operators are connected to is actually reasonably reliable. So we're not talking about running diesel gensets for hundreds and hundreds of hours a year. I mean, they're more of an insurance policy than they are actually a power generation site. And things like HVO help us to move that game incrementally forward because it's better than running on distillate fuels. So I think the desire is there. I don't think that there is I think, like I said, I think it's a balance between being able to achieve a minimum impact, but doing it in a way that's both robust and reliable and also cost effective. And there are examples of data center companies out there that are doing trials on fuel cells, but the technology is still not where it needs to be able to replace the technology that we currently have today. So I think there's a sort of a dual path, really. There's a where we need to get to and a roadmap over the next sort of 2 years, 5 years, 10 years of what can be done today. And then there's a vision of where we need to get to, and also the investment in those technologies, so that I think part of it is about a partnership with those organizations, whether it be the way that the infrastructure in the data center is designed, whether it be how we apply that technology. I think is a mix at this stage. I don't think there's any quick fix to where we currently are. So I don't think that I think the diesel engine will be around for a while yet. We talk to customers about gas, but essentially we're still, when we move to gas, you could argue, well, it's not really any different. It's just a different form of fossil fuel. So I think in the short term, there's a sort of a real push to understand what's possible. But I think everyone appreciates the fact that that's probably a few years down the line before we're actually in a situation where those technologies are reliable enough and the scale that will allow them to actually deploy them in large hyperscale type data centers.
You said obviously that they're, well, thankfully the gensets aren't required to to operate for that long period of time, but the current scenario we're all aware of, again, with the crisis that I suspect some people have seen coming and others seems to have taken totally by surprise, the volatility in power prices and therefore supply as well. Do you think that before things get better in terms of alternative fuel sources kicking in, there may well be a bit more volatility? I'm hoping the data center industry will be one of the last people to be denied power, because obviously it's pretty critical to most aspects. But do you think the data center industry needs to be prepared for a bit more supply volatility, and therefore the backup generators are going to be under scrutiny a bit more, or do you think it's literally I think that's I think that's a distinct possibility. I think at the end of the day, if you look at the demand and you look at the amount of things that we're looking to actually use electricity for, and the current issues that we have around supply, there's an inevitable that there will be probably more of a volatile network out there in certain parts of the world. So yes, you would have to say that the likelihood of relying on a standby power solution is probably going to increase in the short term. And clearly in the short term, we don't have
we don't have a solution for next year. So you're probably correct in that backup power will come under more scrutiny, and I think that's why for us, being able to move towards things like HVO, the ability to install sites with exhaust after treatment to really clean the emissions from the machines when they do operate is critically important. And we're probably further forward in terms of the technology that we can apply than what's actually currently being demanded. There's a lot of sites that we build where we have made provision and design systems to accept after treatment and fit, whether it be SCRs or other pieces of kit, to those gensets at a future date if that is requested. So I can foresee where there are sites that have been built that will ultimately end up being upgraded to reduce the emissions if there is more demand on those pieces of equipment. I think that local authorities have probably taken a view in the past that the network is stable, and the argument has always been it's a standby facility, it'll only run for a certain number of hours a year, so the impact is minimal. I think if we see an increase in the number of hours that standby equipment is called upon due to instability on the network, then I think that those regulations and local authorities will start to impose greater restrictions on what's acceptable from an exhaust point of view. I mean, London being a good example, if you go to certain parts of London, there are large, enormous numbers of diesel gensets, whether they be ours or anybody else's. So an instability in the grid or a network outage in those parts of metropolitan areas would have an impact, because you're going to have a lot of equipment starting. And some of those have been built for 10, 15, 20 years. So they don't actually have the same level of technology or the same level of emissions treatment as what's possible today. So I think, it will come under more scrutiny, and I think that there will be a requirement to fit the best available technology, which may not have been expected in the past.
And just on the actual fuel side of things, I know, I've certainly read and heard about potential issues. If diesel is stored for months and months without actually getting used, there are potential problems when it is suddenly required to fire up a gen. A, do you get involved in helping people, educate people on that? And B, these alternative energy sources, do they have their own sort of storage and then usage issues, or are they easier to fire up from sitting idle for months on end? Just any thoughts on that?
I think, certainly in terms of fuel storage, is something that we do a lot of work on. So a lot of our customers, we install fuel management systems. So we'll actually install fuel polishing systems which remove bacteria, remove sediment, that type of thing from the fuel, so that you don't end up with hundreds of thousands of litres of fuel being wasted that can't be used. One of the two biggest reasons for diesel gensets not starting is batteries being flat because they haven't been tested, or fuel being less than optimum, shall we say, and filter blockages, that sort of thing. So and I think over the years, customers have realised and have understood those issues with storing large amounts of fuel for long periods of time. So it's fairly standard. Part of our solution is to actually provide filtration and polishing equipment to actually maintain fuel quality. In terms of other technologies, yes, there are issues with certain technologies. Diesel engines are very good when you start the machine. You start the machine, and seconds later you've got power available and you can run the site. It's not quite as rapid for some other technologies in terms of time between an outage and the ability to actually provide full power. So again, it's a technology that, when you look at it, it's the diesel technology we apply today. It ticks a lot of boxes in terms of what customers are looking for, and again, we see sites where even when sites are looking at gas gensets, for example, there's still also diesels involved there, because the ability of a gas engine to run up quickly and be able to support a large load is not as good as a diesel engine, similar to your car. Diesel is able to start and provides torque, and a petrol engine is not quite as good, and it's very similar in terms of the science with the gensets. On the fuel cells, I think, again, fuel cells, slightly different technology, but there are warm-up times on fuel cells. There's a lot of work going on in terms of how do you bring fuel cells up to speed quickly. And I think fuel cells probably is part of a solution. I think as we go forward, there will be a combination of technologies, because the ability to start fuel cells probably requires other technologies to give you that initial picking up of a load whilst you actually run things up to be able to deliver what you need as a load requirement. So I think the architecture of how backup power will be designed would change and would be adapted to allow for the differences in the technologies. So I think what we have today is a good solution in terms of what's required at the output level, but obviously we're striving to move towards something that environmentally is seen as being and has an impact that's less driven around the fossil fuel issues.
And obviously today you've outlined the walk-in enclosure, which is aimed at the sort of top end of the market. But you alluded to it in the presentation about edge, and I'm just wondering, I mean, is it as simple as just providing much smaller power supply, or bearing in mind the locations a lot of these edge facilities, is reliability sort of super critical? I'm not saying they aren't normally wrong, but you have to be sort of extra careful to make sure they're reliable. And you mentioned the noise issue. Potentially if they're going to end up on every street corner to control autonomous vehicles, as we're sort of led to believe, the noise, if you can imagine all these kiosks down the road all humming away. So are there some challenges, I guess what I'm saying is, with providing power at the edge?
I mean, inevitably, yeah. Nobody wants something humming away on their street corner, do they? So I mean, I think where we are today, we have a range of products which at the smaller end, we have products that are designed for those types of environments in terms of noise and reliability. I mean, our view with it is, you have customers that are demanding, and any machine downtime is not acceptable, and being able to respond to that quickly and being able to deal with any faults that there might be quickly is something that's really important. So in terms of service levels and being able to actually have people on the ground, and the network we have globally of trained technicians and engineers, and being able to do that is critically important, and part of the consideration that our customers have when they select equipment, whether it be from us or any of our competitors, is around the ability to support the product in the field. In terms of, so I don't think in terms of the reliability, we really see we see all of the applications as critical, so we approach it in the same way. And some of the products that we are looking at for edge have been to some fairly critical environments and locations. One of the products we've got out in the Antarctic, the British Antarctic Survey, so it's been sort of tested and operated in some fairly extreme conditions, with arguably life safety as quite a sort of a key sort of reliability issue. So I think in terms of the way we approach it that yes, it has to be reliable and provide that level of security. Again, I think as we go forward, an edge becomes sort of out to the next level. I think we've seen edge technology in what's sort of historically been sort of semi-industrial type applications. So where you might have had things like telephone exchanges and that sort of stuff in the past, you sort of see it at that level. I think if we get to the level where, like you say, we've got backups on street corners in boxes, then yeah, clearly a genset humming away is not what people want. So again, some of those technologies that we're talking about at the sort of the larger sort of domestic stroke industrial scales, of things like battery technologies and fuel cells start to become quite interesting for those sorts of applications. So, you know, in the short term, yes, we do have products that are capable of doing that, and they are super silent. Some of the work that we did on with our rental product, which again, obviously is, you know, the types of environments that those products go into, whether it be events or sort of locations where people don't want to hear a humming genset. So the engineering that went into building very low noise, reliable units, we've sort of adapted and upgraded even from those products to actually build stuff that's quite good for the edge applications, because of the concept that was originally based around. It's allowed us to use those types of products as a base for building this type of thing.
And maybe just one other thing, potentially related to edge, but more generally, we haven't talked much about sort of intelligence. So I'm guessing once upon a time you just delivered a UPS, it sat there sort of on its own, and you know, people had to go and physically examine it, maintain, etc. I'm presuming that along with the other UPS folks, you're building quite a lot of intelligence to the system. So remote monitoring, management, etc. is another way of making life more efficient for people with them. Yeah,
it is. It's an interesting one, because there's a lot of capability in terms of remote monitoring and remote interrogation. Interestingly, most data center companies don't want to connect here because they see that as being a breach of their security, I guess. So no matter what security you put around it, most of them leave these things unplugged. So they'll monitor locally, and you tend to find most big data center companies we will link our systems, and we have all the protocols to link to all the various different power management and BMS and power systems. So they'll monitor it locally. They'll see that there's an issue, and then they'll pick up the phone and say, we need somebody to come and look at it. They're very reluctant to allow you to leave a machine connected permanently to a network. There's very few of them that I've ever known that have been any different from that. It doesn't seem to make any difference which customer it is. They love the ability to do it. They don't actually want to plug it in.
Right. Can you see that changing? I mean, again, maybe, I don't know, for possibly sort of sustainability, environmental reasons, it being more efficient to allow you trusted partners to do that, or do you think they will still, security of their environment is sort of paramount?
I think I don't know, maybe it tells you something about their view of security in IT. I don't know, but having worked for a couple of manufacturers over the years, it's never been any different. It doesn't seem to make any difference. They see the benefit, but they just don't seem to want to do it. I think again, you know, if you look at opportunities and something that, you know, is possible, you know, that a collaboration with an end user customer, and you're probably looking at, you know, the bigger customers. So, you know, you've got customers like, there are operators out there like Google, Amazon, Microsoft. They all have technology that they use with customers and interface with. You know, we use it every day. Opening web page. Sorry, that was I mentioned a word then, and unfortunately somebody responded to it. There you go. They like to be permanently connected to us. But I think so. I think, you know, if they're part of the solution, then they want to be involved with it. But I think, you know, as a third party, even as a trusted supplier, the ability to connect into a data center on what they see as a critical part of their infrastructure has always been something that's been sort of a holy grail that nobody's ever wanted to do it. You know, but, you know, they might. We tend to find that what happens is if there's a problem, then they'll make a connection to it so that you can interrogate it. But in terms of monitoring it and in terms of having visibility of it 24/7, it's never been something that they've been very keen on allowing access to. But certainly an opportunity.
I think that's covered most of the sort of extra bits I had, so that's good, thanks.